Hello, today I shall be developing Granger Causality test using R software, right? Using R software, and here I have two variables such as cons and LR. So I have these two variables, and now I can develop the Granger causality test using these two variables. And the R software actually is a free software. You can download it from online. Okay, here is the R software. You can see I can make it for you. Here is the R software. You can see R console, it is here, and here first I have to install packages to run this Granger causality test. So install packages. So the name of the package is LM test. So that is my package, and I enter. Then you have to select your area, right? Select your area, then OK. Okay, so it is being downloaded gradually. Okay, I think it has been downloaded. Then write the program library LM test, then enter. Okay, now I have to locate the data. Data is located. It is CSV file. My data is located in C drive under economics 5 folder, and the file name is IMP, and that is CSV format, the file, bracket closed. So that is my data, location of my data, enter. Okay, then afterwards, now I want to see the data. Okay, but first I have to attach my data that I have to attach, and now I want to see the data, how it looks like. Okay, so first I write my file name, data file name, which is IMP, and then I read this data file, then I write file, then choose, then this one, header equal true, right? Then the bracket close, right? Yeah, make sure your programming is all right. So then enter. Okay, then from here our data is located at C drive, and under C drive it is under economics 5 folder, right? Click on it, and the file name is IMP, so I click on it. Okay, then I have to write IMP, the file name, data file name, enter. So you can see our data observation, and I have two variables, cons and LR, right? And data from 1970 until 1990. Okay, now with this data I can develop the Granger causality test that I shall do now gradually. Okay, Granger Causality test. Okay, so so uh, so first I write the comment. Okay, I just 1 minute. I make it little bit small. I make it a little bit small. Okay, I make it small, and I do something here. Just 1 minute. Okay. Okay, here. Okay, so here. Okay, so first I run the Granger Causality test, but first I try with the with the with the with the try with the first I try with the lag 2. So first I try, that means order 2, right? Same meaning, that I try first. Okay, so here I write the command Granger test, right? Then we have two variable Granger test. Just 1 minute. I think command should be like that. Cons, it is our one variable, and by x. So here cons is the dependent variable, LR is the independent variable. Then our order is 2, that means 2 lakhs will be used, and the file name is IMP, right? So that is my setting, data IMP. Okay, then I enter. So that is the result. Okay, here what is the null hypothesis? The null is, so actually you can check from here, LR, right? LR does not cause cons. That is the null hypothesis. LR does not Granger cause cons, right? So that is the null hypothesis. And what is alternative hypothesis? Alternative is LR does Granger cause cons. Okay, here LR means actually lending rate, and cons means actually consumption, right? Okay, so the outcome is here. You can see degree of freedom, right? And F statistics, corresponding probability. So here F statistics is 2.546 and probability is 11.4%. 11.4%. P value is 11.4% when there is 2 lakhs. Okay, here P value is more than 5%. And what is the guideline? If the P value is more than 5%, we cannot reject null hypothesis, rather we accept null hypothesis. But if the P value is less than 5%, we can reject the null hypothesis and can accept the alternative hypothesis. Here P value is 11.4%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that LR does not Granger cause cons. So that is the decision. Okay, now I just change the whole side. I just write it, just I'm changing the whole things. Granger test. So this time I put LR first. LR become dependent, then cons become independent, and order become 2 as before, and data is equal to IMP as before, right? So then I enter. Okay, this is the outcome. Okay, now what is the null hypothesis? Null hypothesis is cons does not Granger cause LR. That is the null hypothesis. Now I am telling again, cons does not Granger cause LR. Okay, and we check the F statistics and corresponding probability. Probability is how much? 47.52%, meaning that more than 5%, meaning that we cannot reject our null hypothesis, rather we accept null hypothesis, meaning that cons does not Granger cause LR. Okay, now what I shall do, I shall change the number of lag. Okay, this time I take lag 4, then I check what happens. So as before, I write the same thing. Okay, first I write cons by LR, then order equal to 4, then data equal to IMP, bracket closed. And here, what is the null hypothesis? It is LR does not Granger cause cons. That is my null hypothesis. I enter. So the result has come up. You can see here is the F statistics and corresponding probability. Probability is 6.075%, which is more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis. And what is our null hypothesis? LR does not Granger cause cons, right? And here lag is 4. Okay, the same thing I'll do. Granger test. Okay, this time I shall take LR first, then cons, then order 4. I maintain the same order or the same lags, data IMP. Okay, now my hypothesis is cons does not Granger cause LR. That is my null hypothesis, and alternative hypothesis is cons does cause LR. Okay, I enter. Okay, here is the F statistics and corresponding probability. Probability is 19.33%, which is more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that cons does not Granger cause LR. Okay, so order 4 we have done. Then we can take one more lag. Maybe we can try with what? we can try with just a minute. We can try with lag 4 we have done. Then we can do with the lag 5. We can try with the lag 5. Granger test as before. Okay, so first I take cons, right, then I take the things and LR, right. So this time lag 5, meaning that order 5, and my data is IMP. Sorry, done mistake. Make sure if you mistake, then result will not come up, so we have to double check. Okay, now what is the null hypothesis? LR does not cause cons, right? That is the null. And alternative, LR does Granger cause cons. Okay, I check, enter. Okay, here the F statistics is 5.5, p-value is 4.153%. P-value is 4.153%, which is more than 5%, meaning that we can reject null hypothesis and can accept alternative hypothesis, meaning that LR does Granger cause cons, meaning that LR does Granger cause cons. Okay, so I do the same thing as before. Granger test by this time I take LR as before, then cons, then I take order 5, then data equal to IMP. Okay, and here our null hypothesis is cons does not Granger cause LR, that is the null, and alternative is cons does Granger cause LR, right? I enter. Here is the F statistics, corresponding probability 20.93%. So we cannot reject null hypothesis, rather we accept null hypothesis, meaning that cons does not Granger cause LR. So here one thing you can see, when the number of lags are changing, the whole thing, the result is changing, right? That means when the number of lags are changing, when the number of lags are changing, the result is changing, right? So lag selection or order selection is very important in Granger causality test. So we have to know which one is the optimum lag to come to a decision, right? So that we cannot solve here. I think lag selection criteria can help you about it, or what I want to say, lag is a very important issue here to take a decision, right? Lag is a very important issue because when we changes the lag, everything is changing. Thank you very much for being with me for a while.